Amy Labrum here from Apian. You will have seen the lecture poster, but they're a logistics company working with the NHS and drones. I'll let you do the full introduction.
Thanks.
No worries.
Thanks for having me. I've opted not to use the microphone. Hopefully you can all hear me. I don't normally have a problem. I have a fairly loud voice. I'll introduce myself quickly. Hopefully it's the least interesting part of this conversation. And if it's the most interesting bit, apologies in advance. I'm going to tell you a bit about who we are, what we're doing. I'm really happy for questions as we go along if you want to clarify things, but obviously that's going to be challenging for our friend with the camera. So if you can hold it till the end, that's great. There'll be plenty of time for that. I'm more inclined for me to speak a little less and let you ask me questions a little more. So we'll kind of just go with the flow on this and see how it works out. So I'm Amy. As Cora said, I'm working for Apian. I'm Director of Operations, so I cover all of our kind of like active business functions. So that's our operations, healthcare, and program management side of the business. So the disclaimer here is I'm not an aviation or a regulation specialist. There will probably be questions you have that I can't answer, so apologies, but I will do my best. I've been working with drone technology for about 5 years. I'm a drone pilot myself. I don't do so much flying anymore, but I did used to, and did used to have the PIFCO, so I can do a little bit of that kind of jazz. I'm not flying drones myself in this project, so I can't really tell you how they work in great detail, but I do know enough to kind of give you some good answers to what questions normally come up. But as I said, we'll go with the flow and see where we get to. So I'm going to be talking about drones in healthcare, drones in the NHS. Our journey as a company, kind of who we are and what we do, and then specifically what we're doing at the moment in London. I'll talk a little bit about the CAA, and I'll talk a little bit about our platform too and our technology. Again, I'm also not a software engineer, so if any of you have got a background in software engineering and have lots of complex questions, I also won't be able to answer those. So this makes it sound like it's going to be rubbish, but I promise it's going to be good, okay? So, Apian. Groundbreaking logistics company. This is the way we like to describe it. Obviously, we would call ourselves groundbreaking. Basically, our mission is to deliver faster, smarter, and greener healthcare. We aren't a drone company. We work with a lot of different drone companies. We work with a lot of different healthcare trusts, a lot of departments, and private healthcare also. We are obsessed with health. We are obsessed with bringing care closer to the home, getting people out of hospital sooner, making sure they can receive the care in the best setting. And we do that because we know that we are all well, we are all better, we are all healthier when we have the opportunity to do that. So the drones are really cool technology. I love drones. I am a bit of a nerd for technology. But as a company, it's all about health. And so that's kind of the angle we look through everything is what can we do to deliver faster, smarter, and greener healthcare. Some of the things we've done in the past, so we did the world's first drone flight of chemotherapy. We also did the UK's first drone prescription delivery in partnership with Boots a couple of years ago. So there's some things that we're quite proud of in our history. The kind of problem that we're looking to solve is healthcare logistics. We know that they're in a chronic condition. We know that it's really, really difficult. We've all had these experiences where you need to have a blood test and you have to come in at a specific time, and then maybe you go home and they call you back and say, sorry, you've got to come in again because we didn't manage to do the test on time because there was a problem with the logistics. So slow lab turnaround times do impact those health outcomes. They also relate to people not going home as soon. They relate to cancelled surgeries or delayed surgeries. Some of you may know people that have been called into hospital for an operation and said, we don't have a bed for you, but if you come, someone else's surgery might get delayed and then we might be able to fit you in. So this is the kind of thing that the NHS is facing, is the fact that the logistics are slowing down the actual healthcare, the thing that the doctors are amazing at and the thing that our NHS does so well, keeping us safe. So we're also looking at overstocking and medicine waste. That's a big problem for us. It means that you'll buy something and have it in your storeroom until it goes out of date, you can't use it, when actually someone over there has also just bought one because they need it. Why can't we share those resources? Why can't we make that way more efficient? We know that road travel accounts for 14% of the total NHS emissions, so that's not just logistics, it's also patient transport, it's obviously people moving around the network. But what we want to do is reduce that CO2 because it's better for us all, it's better for the environment, it's better for our planet. So you can get your groceries delivered in 20 minutes if you live in London. Most people can get on Uber Eats, they can call for a pizza and it can be with you half an hour tops. Why can't healthcare have that same solution? Why can't healthcare be more on demand? So that's kind of where we came from. So this is a visualization of what we would like to see. The NHS air grid. We'd like to see a picture where things can flow through the UK, through the air, without the traffic, without the blockers that are currently in place, that can safely share the airspace. We also know that the drones aren't the only solution, so some of this does look like more efficient ground logistics, electric vehicles, better centralised stocking mechanisms. This autonomous healthcare supply chain is really, really important to how the NHS evolves, particularly with our ageing population. Now, as a business, we are born out of the NHS. 2 of our 3 co-founders were junior doctors in the NHS. They went to university, they absolutely were sure they wanted to help people, they wanted to care for people, they wanted to care for the sick, they did their studies, they went into their hospital rotations, and there were occasions where they were in the surgery observing and someone said, we need this thing, can you get a taxi? And they would spend 2 to 2.5 hours taxiing around London, collecting parts from other departments or other hospitals in the area for an emergency surgery. And they kind of sat together, they had this interest in kind of robotics and automation, and they said, okay, as a doctor, I can see, depending on the specialty, between 5 and 50 people a day, depending what I do, and I can help those people every day. Or I can try and solve this logistics problem, and I can save millions of people, I can help millions of people, I can help people that work for the NHS as well as the people who are being cared for by it, and healthcare broadly. So they met up with Alex, who's ex-Google Health, and the 3 of them founded Apian with this mission in mind. So we exist in this kind of nice little gap in the middle. So we know that the healthcare industry wants to focus on helping people, caring for people in a wide spectrum of ways. We know that the drone industry wants to fly drones. We know particularly in the UK that there is significant interest in this emerging technology and in this kind of new industry. And what we know is that healthcare people aren't experts in drones, and drones people are not experts in healthcare, and neither should they be. But actually we're uniquely placed in that market to say, well, we come out of healthcare, we have, I'm totally biased, but a world-class aviation regulatory team who work closely with the CAA and that help to build these solutions for us. And then now I'm really proud to say that we're out there doing it. So that's kind of where we fit in this picture. And I'm just going to flick through these. So we've kind of talked about this. We know about the patient care, we know it's better. Obviously the cost savings are a big part of this too. So let's talk a little bit about what we've done in the past. So I talked about where we came from. I can certainly talk about my time at Apian, which is just over 2 years, and in that time we've run a number of trials. We worked up in Northumbria on healthcare trial. Northumbria Trust is one of the UK's most rural, and so they have significant challenges around moving things from site to site. It's a really long way, and if any of you have been up to Northumberland, you'll know there's one main spine road. It's not a significant motorway, it's quite a small road, and it often is congested. If there's one accident or something goes wrong or a road closure, it leads to hours-long delays, which does lead to real problems in the healthcare system. Also up there in Northumberland there is an ageing population. It's a beautiful part of the world. If you haven't been before, I can highly recommend it. I spent a lot of time up there working with our partners on that project, Skyports. So we did the UK's first medical device delivery by drone as part of that project. We did the UK's longest drone delivery. It was an 80-kilometre delivery, so that was a pretty cool thing to be a part of. And we did the first flight of blood packs for research working with NHSBT. So as part of that project, we really tried to get inside who Apian could be as a part of this picture. We had the start of what we now know as Apian's platform, which is integrating these services together, but at the time it was just a spreadsheet. It was a spreadsheet where we could estimate what time a drone would take off, and someone at the hospital could kind of type a time in and book that delivery by confirming that time, and we'd pick up the supplies, get them in the drone, and they could see what time it was due to arrive, and they could check it in on the other end just all through one shared spreadsheet. That significantly has evolved since then. We have a wonderful platform that kind of I will run you through and I will show you how it works. More recently, just last year, we ran a project over in Dublin, which is currently on pause, just waiting for its next generation, its next phase. We were working with Medtronic and with 2 hospitals over there to move medical devices through their network. We were able to do a significant improvement on their current logistics. So they had a turnaround time from order of around 2 days, which is like a standard SLA, we'll deliver it within 2 days. We were able to deliver it within 20 minutes of order. So that means that instead of having a big room full of stock at the hospital, we centralise the stock with us. We can get the device just before the surgery, essentially, and that room could be given over to patient care, to staff well-being, or to other useful medical reasons. That project was the first time we worked with Wing. Wing are an Alphabet company, so part of the kind of Google family, who we partnered with on that. Wing we are still working with, and I'm going to talk a little bit more about them in detail now as it relates to the work we're currently doing. So I just pulled these stats from Wing's website, I'm sure they won't mind. So they've done more than 450,000 residential deliveries across 3 continents. We chose to partner with Wing because of their experience, because of their safety record, because of their interest in being a part of improving healthcare in the UK. Their fastest delivery time across the whole network is 2 minutes and 47 seconds, and they've got 12 plus years of innovation from the labs of Google. And this is just a picture of kind of their library of drones. The sort of medium-sized ones here you can see are the ones that we are using here in the UK. And if I flip to the next slide, I'll show you our setup, and then I'll talk a bit about the project. So we, in partnership with Wing, opened what we like to call the NHS Drone Delivery Hub 1. That is based at Guy's Hospital in London. We opened the hub in October of last year, and we got a lovely branded NHS delivery box there, so that's what we use to do our current project. So we have been working in London for nearly 6 months now on a trial with Guy's Hospital and St Thomas's Hospital. We are transporting pathology samples between these 2 hospitals. What currently would happen without the drone is that once every 2 hours a courier would get to the hospital. They would move through the hospital to all the different departments, picking up things as they go. They'd get back in their vehicle, and the ground journey, which is not very far, can take between 20 and 45 minutes depending on the traffic. And so that means that supplies are kind of on this 2 to 3 hour cycle, like best case, moving from lab to lab. So we kind of identified that that's something we could do better. So what happens now between Guy's Hospital and St Thomas's Hospital is a member of the lab staff packs a load of samples that need to be transported to St Thomas's. They book it all on their system, and our platform integrates with their current booking system. Identifies to me and my team that we've got a drone collection. We're integrated with the portering system, so a porter picks it up, pops it to the location where the drone takeoff point is, our drone hub 1. Loaded into the drone, and approximately 2.5 to 3 minutes later it is delivered to our drone delivery area over in St Thomas's. The porter picks it up, and within 3 minutes it's in the lab, checked in and ready. So that means that something that could take 2 to 3 hours is down to, it could be 20 minutes, right, for the whole process, booking in, getting it all the way and over there. I'm going to flip to the next slide and just show you a quick video of the operation and talk you through where we are. So that's now going to play on a loop and really annoy you and mean that you absolutely can't concentrate on anything else I'm saying. When I watch this video, I always think, you'd think we picked it just for the views, right? It's a pretty spectacular location to be flying drones. Certainly when I joined Apian, there were a number of people who said to me, it can't possibly happen. You can't possibly be suggesting you're going to fly drones across central London, right by the Houses of Parliament and London Eye. And I do like a challenge, and so that didn't dissuade me from joining the company. I'm incredibly proud of the work we've done to date, but I am even more excited of what comes next for us. But in terms of what we're doing right now, we should just stop and talk about that. So we're delivering pathology samples of numerous types, going between these sites. We have delivered over 3,000 samples, which is nearly 3,000 patients we've helped. In terms of the ratio, we know that the van around 30, the drone around 2 minutes, so it is a big difference. The benefits, it's interesting, it would be obvious to talk about the time saving in terms of the benefits. Of course it's quicker, and so obviously there's also fewer emissions, so we know that you're not sending a diesel powered van, or you are sending an electric drone. But these kind of second order benefits that we've already talked about, the cancelled and postponed surgeries and the wastage, I think where the really interesting part is. And the other thing that I have discovered since I've started doing this project is that there are a lot of processes in the hospital that are very manual and very tiring on the staff side. So if a sample has to be checked in within a certain time window, when a lab staff books it in and sends it, a kind of timer starts, and if they haven't seen on their internal system that it's arrived, they have to start ringing and saying, hey, I sent a sample 2 hours ago and it hasn't arrived, where is it? With our platform, they don't have to do that because it's fully traceable end to end, so they can see when the drone has delivered the parcel and they can see when it's arrived in the lab. So those kind of benefits that take away the decision-making fatigue do make a big difference. Just pause and check that you're all still with me.
Yeah.
Good.
Yeah.
Good. Hopefully you do find it more interesting than just me telling you who I was. I think we're okay. I'm going to cover this in brief. As I've told you, I'm not a regulation expert, I'm not an aviation expert. I've got a couple of slides that just show visualizations I'm confident you will have seen before that the CAA have put out publicly in the past. The thing I would say is that I wouldn't be here, and we wouldn't be here, we wouldn't be flying in London without the CAA. In my career working in drones, I've certainly been exposed to trying to operate in lots of different airspaces and in lots of different environments, and I know that there are significant challenges, but I am a big supporter of the CAA, and we are as Apian big supporters of the CAA because they have enabled where we are now. We are excited to continue working with them on where we go next, how we grow and how we scale. So our journey has been through the CAA regulatory sandbox to get us up and operating in London. We are operating in a TRA at the moment. So we have a single block of airspace that's reserved for us. We have procedures in place that mean that if anyone needs to use it, particularly obviously emergency services, but also other airspace users, they can contact us. We have procedures to make it safe, and of course the priority is given to emergency services. That is natural. There is no way we would want it any other way. We want the police or heli-med to be able to do their good work safely. Because our journey time is so short, we have the benefit of being able to complete our journeys quite quickly in between anything else. So far we've integrated successfully. We've had minimal disruption on either side, and that's been great. CAA have obviously helped set out guidelines that enable us to do that through the sandbox. You will, I'm sure, have all seen this Future Flight Action Plan. We kind of always flash this on to kind of show, what the journey has to be according to the CAA, or what the kind of the trajectory has always been set out by them. Integrated airspace at scale is kind of the buzzword. You will hear people talking about it. The scale thing is the thing for me too, though, right? So we have a wonderful operation in London. We're really, really proud of what we do, but we know we can do more. And to be able to unlock that is a journey for all of us, as well as looking at integrating with general aviation and unsegregated airspace. So obviously at the moment we're operating in London. That presents unique challenges, but also unique opportunities, because what you haven't got is a large general aviation component who are quite rightly and freely using the airspace to fly around. Some of you may well be part of that community. And a lot of our airspace is given out to that, and that's wonderful. By choosing to operate in London, while it's challenging, what we've been able to do is operate in a slightly different environment, which has given us the opportunities we have to date. So we kind of look at this and we say, well, where did the CAA want us to be in 2025? Atypical air environments, that's kind of where we are at the start of our journey. BVLOS in uncontrolled airspace supported by ground infrastructure. So we're starting to see some of these things out there in terms of demonstrations and trials. I think there's a big journey for us all to go on. I'll be interested to see what the next thing that comes out is and how that kind of steers us. But yeah, that's just a little touch on that. So I have raced through this really, really quickly. I'm going to talk to you a bit about Apian's platform, and then there'll be loads of time for questions. That's pretty usual for me in my presentations, so don't freak out that you're going to have to fill loads of dead air. I'm really, really happy to talk in more detail about anything we've done so far. So this is just a visualization of what we are building. So I talked about that integration point, the fact that a member of a healthcare team can book something and our system will pick it up and identify how it needs to be transported and get that kind of booked and integrated with the system. So we are working to integrate with EHR, electronic health record systems, and laboratory information management systems, which is a mouthful, particularly when you have braces. So we're doing that work that means it's so easy for people who work in healthcare to be a part of this network, because they don't have to do anything different. They just do exactly what they do now. They book things in the same way, or they order medication in the same way. Our system will interpret that information and it will decide the best way for that to be transported. So mostly it's going to be drones. Certainly in the early days of our operations, we're going to be demonstrating the use of drones to speed it up. But as I've said, the picture is not only drones, it's other kinds of electric vehicles. One of my colleagues likes to say, we don't really mind if it goes via a clown on a unicycle, as long as it gets there as quickly and as efficiently as possible. And so if the clown on the unicycle is the nearest person that's on our delivery network, we would send it that way. So that kind of like routing is a really important part of it. But as I've said, we talk about drones because we know that they can make a significant difference, particularly in London. We're seeing that every day. So then on the other side, you've got our drone operators who are integrating with us, so we're integrated with us, which has been great, which means their system and our system talk seamlessly to each other. It means, again, that I don't have to pick up the phone or send a message that says, hey, we've got an order, do you want it? It just automatically loads into their system. And then we've obviously got ground operators, we've got like my interfaces for my team, and then payload monitoring as well. So that's obviously making sure that the package is safe, it's not too hot, too cold, shaken around too much, so we know, and we've tested all of these things before we go into a live environment. And then in the future we will have active monitoring of various specific use cases that would require it. So this is our current healthcare interface. So this is currently what our lab staff can see if they want to book in an order, or should they say, they don't necessarily have to look at this because much of it is done for them. So they can select what they want to transport, how many of them want to go, or our system does that for them, and then they can see the journey of that. So we talked about that full traceability. So the order's created, it's on its way, and it's complete. That's a real benefit for them. On the other side, we've got our what we call our TMS, our delivery interface. That kind of tracks the order, and that gives us full visibility of the drones in the sky, which is great. We also have a simulator that we built that just helps kind of show what is possible that we've been using, and we also have a departure board which kind of shows the current operations. So of come to the end of my slides. I'm going to talk a little bit about the drone and its technology. I'm going to talk to you a bit about specifically the drone, because I'm sure you are interested in that. So Wings drone, which I showed you pictures of earlier, it cruises at around 100 kilometres an hour, so it's pretty quick. Obviously has vertical takeoff. It's really, really quiet. It's been designed specifically for seamless integration into the community and the airspace. So that means they've worked on the propellers, making sure they are as quiet as they possibly can be. They are highly, highly automated. So when an ROR system tells them there's an order, that kind of loads up in their system. The drone itself decides and plans its own route. It varies that route, so it's not going over the same house every time. It's not going over the same field or the same kind of people on multiple occasions. And these are some of the things that particularly appeal to us about working with Wing. You know, every operator has their own kind of real benefits, but that was one of the things we saw with Wing, is that we could kind of see the way they want to be a part of the communities they operate in. So while it does have cameras on board, and that's just for kind of mapping redundancy, there's kind of no high-res filming that goes on a Wing drone, so we don't have any privacy concerns, which is really helpful in community engagement. Wing also have an amazing community engagement team that have worked with us when we started in London to get out to the community and talk to them and tell them about what we were doing and what we wanted to achieve, and that was so that people could ask questions. You know, we do come across the same kind of concerns about privacy, about what would happen if something went wrong. The honest answer is that it doesn't. It's a system that is designed with significant redundancy and safety. The journey time is really short. The pilot in command that they have, that is more like an air traffic controller, is sat a little while away from our operations in St Pancras, so they can't actually see the drone. It's a true BVLOS operation. And they can only do a limited amount of things, so they can tell the drone to land now, or they can tell it to get back to base. They can't get a joystick out and control it. These systems are just designed to be as safe as possible. We have procedures in place for if there were to be an accident or an incident. We practice them. We hope to never need them. We've not needed them yet. The way that the drone works in terms of its actual delivery mechanism is really interesting. So the drone takes off and then releases a cable with a small hook on it, which the package is attached to, and that goes up and kind of is firmly lodged in the bottom of the drone. The drone goes to its delivery point, detects its delivery point, and then gently lowers that package to the ground automatically. So yeah, it gently lowers that package to the ground and leaves it there, and returns its journey. So it really doesn't need someone waiting there to unload it, so that reduces the kind of human interface. We do have obviously amazing porters at St Thomas's Hospital that come and pick it up, take it to its end location, but we can kind of deliver a couple of things to the same spot and the porter can come and take them all, so it works really well in terms of that efficiency and that kind of like time saving too. So when it comes to payload monitoring, we're largely concerned with temperature, and that's due to the nature of what we're currently transporting. Pathology samples have a specific requirement to be kept at what is technically known as room temperature, and it has to be kept at that temperature from the moment it leaves the first lab to the moment it arrives at the second lab. Now, what's interesting is in a ground transportation environment, it's kind of given that because there's a human in the loop, they're not going to have their van at 30 degrees, because that would be crazy. That would be way too hot for a person. And so actually we've had to give ourselves even harder a requirement than what is seen in current logistics, and that's because we want to be absolutely certain that it's safe and that we're doing the right thing. And what we hope is that by proving out this technology, we're building up like a bank of evidence, we'll be able to roll it out quicker in future. So we did significant amounts of testing in the early days, and that was that first we carried essentially empty boxes with just temperature loggers in there to kind of see what the ambient temperature was inside the box. We then have the canister that you saw in the video. We then checked the temperature inside the canister compared to the ambient temperature. We then carried water samples first. We then carried split samples. So we sent half by road, half by drone, and we compared the results to be absolutely certain there was nothing we were doing that was going to impact the results.
Well, I think I speak on behalf of all of us in saying it was an incredible lecture. So thank you.